Hello, my name is Hugo Villemain. I'm the Algae project manager at Synoxis Algae, and I'm here to show you the laboratory and the photobioreactors. So what I do is I test the photobioreactors and I lead also the algae culture. So Paul just explained to you the salt movement. So that's what we have here. So we have vertical tubes and then the lid that allow to have a spinning movement inside. So you increase the biomass, you decrease the appearance of the biofilm, and you also increase the light that can go inside. With that, you can get a high concentration of microalgae or cyanobacteria. We are going to see all the other photobioreactors. So here is the laboratory. It's here that we build, we test, and we develop the photobioreactor. It's also here that we manage the algae culture so that we can advise our customer on how to do a continuous, a batch, a semi-continuous culture. We also train people here in this laboratory. So before going and before shipping the photobioreactor to their facility, they can come here and they can use with us the photobioreactor so that they know how to use everything on the photobioreactor. We also have school and people coming here if they want to learn a little bit more about the algae or just to know how it works and after get one to their home or facility. So here we have the nano. So this nano is the smallest photobioreactor what you have with a 3-liter chamber. It's for one the nano salt and it's a salt movement inside. So that's what we have here. The salt movement is made with this chamber that you can put in the autoclave or that you can disinfect with chemical products. So here we have nanochloropsis inside and we are testing the nanochloropsis with both water and the nutrients. So if I want to change the light, I can just click here and increase the light if I can see that my culture is growing. The nano, basically, is the plug and experiment model. So you can increase the light, you can inject the nutrients, take out a sample if you want to measure the biomass, or you can harvest everything and use it for your research and extract the molecules or what you need. That's what we have with nano. Here is the nano with a 30-liter chamber. So the movement is a bit different. We don't have a spinning movement. We just have 1 point of bubbling at the bottom of the tank. And in this one, the ratio surface per volume of culture is a bit different. So it depends if you want to test both the salt, both this one. In this one, we have the same algae. But if you want to test a species in this one and another species in this one, you can try it. You can also put 2 nanosalt chamber, one and one, and you can control the 2 chamber independently. So that's something really cool with nano, which is a plug and experiment. So here we have a controller of nano. So as I said, you can control both chamber independently. So if you want to increase the light on this one and decrease the light on this one, of course you can. So here, for example, I can just increase the light to 40% and I can see that the light is increasing. So I can adjust the light for both photobioreactors. I can have also an option with red, green and blue lights if I want to manage a spectrum of the nano. On this one, if you want, I can inject the nutrients, let's say 5 milliliters because the algae want to grow in the growth chamber. So I can inject it. I can follow the parameters. I can follow the pH, for example, throughout the day. I can follow also the temperature. And then, with the controller, I can manage the pH regulation and the temperature regulation. So basically, I can do what I want. I can let the culture by itself and come back 1 week after and see the results and measure the biomass. So that's what I can do with nano. So here we have Lucy. Lucy is basically the plug-and-play system. You can move it because it's on wheels, and then you can move it around. You can produce and you can play and do your research with it. So this one is mostly suitable for school, for example, for a research center, or maybe for aquaculture facility, if they want to begin a small production with a growth chamber of 16 liters. The thing is, with nano and this one, and the other photobioreactor, we have the same controller. So you will not get lost with the controller. You can manage everything like we do with nano and the others. I can increase the light, I can inject and take out samples. And this one, you can increase the light up to 1000 micromoles, so it will be a lot for the culture. So you can get high concentration, almost 10 times the concentration that you get in traditional system. Lucy is also a tool that you can use for the inoculation. If you have bigger system that you want to inoculate, you can use UC to produce the inoculum, so that you avoid the phase with the Erlenmeyer, a 10-liter tank, 30-liter tank, and then you inject everything in a 100-liter tank. You avoid all of that thing, and the photobioreactor is doing the job for you. So that's the good thing with UC. And this one is Jumbo. It's the biggest photobioreactor that we have in the catalog. This one is a 300-liter photobioreactor, and we use it to produce big inoculum for bigger tanks. The nice thing is I use all the photobioreactors here, and basically it's a scale-up between all the photobioreactors. I begin to use the small one, then the middle one, and then the big one. With Jumbo, you can produce a lot of biomass in continuous, semi-continuous culture, and the culture is safe. It means you will stabilize the culture inside, and you will harvest when you want the culture. It's a nice thing because if I want one day to change the algae or the species, I can do a CIP, and it's called also a cleaning in place. With chemical products, I will clean both the organic and inorganic matter, and the day after I can come back and inoculate my photobioreactors without doing anything, without disassembling anything, and that's something really great in the lab. So that's it for the lab. Thanks for having me, and I hope you like the place where the innovation is made, where we build, we create, and we test and develop all the photobioreactors that we have, from Nano to Lucy to Jumbo. Thanks, guys, and cheers!